All right. For whoever's here, fantastic. Welcome to the session. My name is Genie Yuan. I am the head of field engineering in Asia Pacific for Couchbase. I'm also doing some teaching at the university as well. So my entire background is about data solution delivery. So from analytics. To application building, a full stack end to end. I start my career at the enterprise and very quickly move into consulting and doing project delivery for a lot of data related projects. So today I'm very pleased to stand on the stage to share with you some of our thoughts in terms of how we can actually leverage Couchbase to build new application using microservices. So yesterday, we actually had a session by Jeff. Jeff actually talked about redesigning the architecture. So if you missed that, no worries. We're going to cover part of it. Just give someone whoever missed yesterday's session a bit of refresh. But today we're going to focus on talked about two topics mainly. The first one is how do you actually build a new application in microservices in Couchbase? We're going to talk about some of the very specific details around the patterns, right? Also, when you are actually trying to modernize some application from monolithic architecture, what do you do, and how Couchbase can help you on that? Right. So first of all, let's talk about some key aspects of the microservices. I'm not here to redefine microservices. I think nowadays the enterprise knows how to define, and this is not a new terms anymore, right? So I think that the definition is well known, but today we're going to focus on talk about some key aspects of it. As you can see on the diagram here, if we need to develop and design a microservice architecture successfully, we need to have some of those attributes. The first one is about scalability, right? So obviously the microservices need to be able to scale, to go when we actually have more services coming in, we need to be able to scale up and scale out. When we have less traffic, then we need to be able to scale down. The other aspect of that is high availability, right? So the microservices in each of the services that actually need to be, self-contained, but at the same time need to be highly available, right? If that service is not available and other services or the application is depending on that services, I believe we actually have trouble of maintaining that, right? So high availability is very, very important. And also in terms of isolations, right? One of the very key concept of the isolation is not only happens at the application level, but also at the database level, the data layer as well. So for example, in the diagram, you can actually see the product microservices. For it to talk to the data itself, we want to get down to the schemas, to the table. We want to isolate it. We want to have access to that particular set of data, while other microservices don't really have access to that. All right. So in this case, we have to, hide the database implementation details behind the services. When you need to access those data, you access to that microservices. For example, in this case is product. If you want to change the product table, you actually need to talk through the product microservices instead. So in this case, you don't actually have access to the underlying data directly, but everything is through that microservices, product microservices. Now, How does actually Couchbase help in that sense? Let's quickly look into some of the requirements of the modern database. Traditionally, we have small numbers of users. When we have a single server, when we have a transaction, we actually need the storage efficiency, etc., etc. But nowadays, modern application require a lot more. We actually need the scalability, the flexibility to actually accommodate agile development, right? We also need the scalability and performance to actually match the user experience. And also very important in this case, we have the microservices architecture come in to help to make that structure a lot more flexible, where this experience also needs to extend it to the edge devices like the mobile phone, some of the IoT devices, etc., etc. Traditionally, those are two very distinct sets of requirements. That's why we have RDBMS database, which normally can't have the ability to scale and perform, while the NoSQL does not have the capability of align with transaction, have the consistency and integrity. Fortunately, Couchbase come with a solution that we are able to accommodate requirements from both ends. So how do we do that? Remember in the first slide that we actually talk about scalability, right? In order to achieve that, Couchbase have a function called the MDS, right? The multidimensional scaling. In this case, you can actually install all the services into a single node or the same set of nodes. At the same time, you can actually install the services on different sets of nodes. So in this case, on the right, you can actually see index and query sits on node number 1, 2, and 3, and 4, while data sits on 5, 6, 7. A very simple example, if your data volume doesn't change, but you all in a sudden have additional requests coming in, instead of scaling the entire cluster, in return, you can scale up or scale out the index or query services in isolation. So this actually helps to give you flexibility and also drive lower total cost of ownership, the TCO as well. Vice versa, while your transaction volume doesn't change much, but all in a sudden you need to actually have a lot more data volume, you don't need to actually touch your index and query services. What you need to do is just expanding, node 5, 6, 7 to additional 2 nodes or 3 nodes, or even more, depends on your requirements. And also you can actually scale up, right? So in this case, data services, which is what we call the key value operation, is memory intensive but not CPU intensive. In this case, you can actually have different machines, different specs of the machine to actually accommodate the data node versus index and query is a lot more CPU intensive. So in this case, you probably have a different set of machine for your index and query, while a much smaller CPU set with a lot higher memory for the data. So in this case, we actually have the flexibility to scale your cluster in different ways. And also, when we talk about scaling, we cannot avoid talking about how do we do that. Couchbase has what we call the autonomous operator, where the autonomous operator, it is a Kubernetes plugin that help Kubernetes to understand how Kubernetes can use to manage a stateful database. I believe for most of you are very familiar with Kubernetes, that you understand Kubernetes is fantastic for scaling deploying the stateless services, but with stateful database, Couchbase is one of the first vendor working closely with Kubernetes to come up with the plugin so that Kubernetes know how to do the deployments. What that means is, as long as you have a Kubernetes cluster, we are able to deploy Couchbase on public cloud, any of the vendors, any private cloud that you're running, or on-prem. With another feature which we're going to touch on, which is cross data center replication, we built a cloud agnostic application, which is pretty powerful. So apart from the scalability we talked about, the second element was high availability. So in this case, we were actually talking about two aspects of it. One is within the cluster replication. The other one is cross data center replication. So one of the very key concept is called the data change protocol. It's actually a in-memory service bus that carry the mutation of the KV store, the key value, the document store, that actually replicated within the cluster. And later on, we talk about the cross data center as well. So what happened is, when we actually have, assuming we have a replicate of our data, so we set the replication equal to 1. So that means we have 2 copies of the data. One is active, one is replicate. So the replicate data will actually get stored in a different nodes than the active data. In the case of node failure, right, the replicate will get promoted to the active node. All right. The replicate will actually get promoted as the active copy in a different node. At the same time, the SDK will have, or the client side will have, what we call a cluster map. The cluster map will get updated automatically. That means from the application, you will know exactly where you should retrieve the data from. So originally, I tried to retrieve this piece of data from node number 1, but node number 1 is no longer available, right? So the cluster map will get automatically updated to say, now your data is in node number 2, go and retrieve that from node number 2. So in this case, within few seconds, the failover or the auto failover will kick in, okay? And the application will not get impacted as long as you have very good, exception handling with the retries. Okay, so from an end user perspective, they don't even notice the backend node was interrupted. With the cross data center replication, in this case, we refer to XDCR. This actually allows data to be replicated across different clusters, regardless where they are. We have many use cases that indicate the data can be in any of the cloud vendor or public cloud, or it can be on private cloud, or it even could be on-prem. So you can actually set up a cluster ring with active passive, or active passive, or active passive archive, right? And your passive could be, or your archives should be sitting on-prem, where your active could be sitting on one continent, the other active could be sitting on the other continent. Then your passive or your archive sits on-prem. So as long as there is internet traffic, we are able to copy the data across the data center using the DCP stream. So both XDCR and many other services that we're going to touch on is a consumer of the DCP. So the DCP stream will pick up all the mutation from the KV store, and then XDCR will actually pick it up and say, yep, I received a mutation. Now I want to pass it on to my target. So XDCR will actually act as an agent to copy the data from one place to another. And also XDCR can perform in two different ways. One is what we call the unidirection, which is from one place to another, one direction, or we can do bidirectional. That means the data can travel between 2 different places. There are 2 directions. And also the XDCR can be filtered. So you do not have to copy the entire set of data across. You can actually filter that down to smaller or more granular level. Later on, we'll actually explain how that works. So after we actually talk about the availability and scaling, let's very quickly talk about what Couchbase can do to help with the isolation. So let's quickly introduce, a few concepts for those one who are not familiar with Couchbase. In relational database, we have server database, schema table, and a record, a row, right? In Couchbase, we have the corresponding cluster, bucket. Bucket is equivalent to database. And we have scope and collections. Scope is actually mimics the schema, while collection is a collections of documents that is equivalent to the tables. While the bucket is a physical separation of all the documents, scope and collection are logical groupings of the document itself. So on the left-hand side, you can see one cluster can have up to 30 buckets, and each bucket can have up to 100 scope. Excuse me. Each scope can have up to 1,000 collections, and one collection can have many documents. So in this case, how does that help? As I just mentioned that, from one place to another, with XDCR, we can actually help to further isolate. We can actually set up role-based access. We can say, hey, we only want, the scope of prod from one place to move into another. So when you're actually doing the cross data center replication to make high availability, make active across the board, we can actually isolate what data need to be copied across. So in this case, let me spend a little bit of time to give you some ideas about different patterns of the microservices architecture within Couchbase. So the first pattern is what we call the dedicated Couchbase cluster per microservices. This is very straightforward. Each of the microservices will have a dedicated Couchbase cluster. All right. So in this case, the advantage of that is you have complete isolation, not only on the data, but also on user, number of resources, security premise could be set up very, very tight around that cluster. Okay, so it's a complete physical separation. Also, it is you can actually put that into different area as well. So in this case, we have the advantage of having everything completely isolated. Pattern number 2 is what we call the isolation using bucket. In this case, you still sit in the same cluster, but you have a physical separation of each of the bucket. That means you have different databases in the RDBMS world. So in this case, as you can see, each of the microservices is corresponding to each of the buckets. Product goes into product bucket, campaign goes to campaign bucket, and so on and so forth. The advantage of that is it is less expensive than setting up a cluster for each of the buckets. All right, but you still have controls of memory allocation for the bucket, and you still can have access control for each of those one, right? In this case, you can still avoid what we call the noisy neighbor to a certain extent, because each of the bucket will actually have amount of memory allocated to it. However, what it cannot do, like the isolation by using Couchbase cluster, is that you cannot avoid noisy neighbor in terms of whatever they are at the user level. So we cannot actually set resource allocation at the user level for them. Okay, I just saw a chat coming in asking about tutorial for how to set up high availability system with Couchbase using Kubernetes. Sure. So let me take that, and I'll probably share towards the end, and we can adjust that. So another pattern is we're coming down even further. So this time, remember I talked about collections and scope. They are a logical separation of the documents. So in this case, each of them referring to in this particular example, I'm only using collections, but for sure we can actually do both scope and the collection at the same time. But for illustration purpose, I'm just using collections for now. So each of the services actually map to a particular logical collection. In this case, you can actually have, if you remember, each of the bucket can have up to 100 scope, and each scope can have 1,000 collections. So if you have many microservices, this is a very cost-effective way. So this will still allow you to do a logical separation with role-based access control, so that for certain user can only see certain amounts of data with the collection of all of those JSON document below. Okay, so in this case, it will be a separation at the collection or the scope level, which is biological separation. Again, the challenge for that is you won't be able to avoid any noisy neighbor situation in terms of the resource contention. Okay, so that's a design decision that you need to evaluate. Last but not least is isolation using all of those above. For example, you can actually have a combination of, bucket, in this particular example, the buckets product will have the products and campaign, all right? And then you can actually isolate it and encapsulate that in that particular bucket, while the other that sits in a different bucket. And obviously, you also can have different databases, different clusters and different buckets down to different scopes and different levels, right? So all in all, that actually gives you a lot of flexibility. If you need, very strict resource isolation, you probably want to go, the level up using, clusters and buckets. But while you actually have hundreds and thousands of microservices, you want a cost-effective way, and you don't have too much of concern on the workload, on the resource constraint, then it's a good idea to using the scope and collections for your isolations. I hope that makes sense so far. So those are the 4 patterns I want to actually share with you in terms of, when you are building a new application, what can you do? What are the available patterns in microservices architecture? And with all of those great things around, great features around scalability, high availability, with Kubernetes to be able to scale, and I hope that makes sense to you. So let me just pause here and see whether you have any questions or concerns before I move into the next chapter, talk about the monolithic application, how we can actually modernize it. Okay, I guess I don't see any questions on the chat, and I don't hear anyone was telling me about that. So I presume we're all good. Let's move into the next topics about how we can actually modernize our application. Now, when you actually talk about modernizing application, you're probably talking about a number of aspects. You're probably talking about on the overall architecture perspective, beforehand you have monolithic architecture. Now you want to move into microservices architecture. But at the same time, you also talk about, how the backend database can help to evolve at the same time, right? So while we're actually looking at the monolithic architecture and the microservices architecture, this is not a straightforward as let's just change the backend database or let's just change the front-end application. It is a journey that requires both front-end application and the backend database to change. When I say that is a journey, that means to go through this journey, we have different options, right? And for the next 20 minutes or so, what I would like to do is share with you what are the options that we commonly encounter and how Couchbase can, again, help you to provide you with a lot more advantage to, on each of those options. So option number one is what I call lift and shift, then modernize. What that means is we will actually help to lift and shift the backend database. And then on the journey, we can, while you are actually doing the front-end application modernization from monolithic to microservices. Now, this is not a obvious options, or maybe it was too obvious, but people don't normally choose this option because of some of the challenges. So first of all, there are two questions out there. What is required for database migration? More specifically, from a RDBMS database to a NoSQL database, right? We actually talk about the NoSQL database have such a amazing capability that can scale, that have the high availability, that all makes good sense. But what does it require when we need to do that? So normally there are three types of consideration. First of all, we all understand that we need to think about the data modeling. RDBMS is highly normalized schemas, tables, structures, while NoSQL tends to be de-normalized. Okay, so what is the effort? Most of the people get scared by, hold on, is that a great effort? Do I need to change all of my data model? How long does it take for me to do? Etc., etc. So the entire migration become a mission impossible. The second consideration is ANSI compliance. How do we actually support the ANSI transactions in order to ensure the data consistency, right? So again, in NoSQL, it was very famous that, database will treat each of the documents just as a document. They don't care what's inside the document. So in this case, how do we ensure, how do we conform, how do we make sure that the data in the document is consistent with data in the other document, right? This is another big question mark. And obviously there are some other requirements from application and the databases as well, all right? So what I would like to show you is how Couchbase is solving that problem. How can it become a lift and shift for the database migrations? So first of all, if you remember, I talked about the mirror, right? When you actually have a database, you mirror back to our buckets, your schemas come to our scope, your tables come to our collections. That means Couchbase can work with a normalized schema. It will just work. You don't have to. Obviously, if you need to gain a lot more performance, right? Yeah, sure, you can actually change, or I think you should change the database schema as well. But to kickstart, you don't have to, because Couchbase understand the pain. Couchbase actually have the scopes and collection there to help you to do a one-to-one mapping back to your tables, back to your schemas. So in this case, it allows you to do a very quick mappings to your tables, your schemas, to your database, Okay, so it is no longer a problem for Couchbase to handle the same normalized way. And obviously, as I mentioned before, right, it is a journey. That means moving forward, you still want to denormalize your underlying data model in order to achieve a lot more flexibility, to achieve a lot more performance, for sure. But this will give you a flexibility to kickstart very, very quickly, okay? And then over time, then you can just change the underlying data model to a certain extent to actually achieve the outcome that you want. But we provide you with that capability to shift or move away from the RDBMS database. At the same time, Couchbase support APIscene transactions. So on in the table here, I'm not sure whether it's too small, a bit of eyesight test, my apologies, but you can see that in the second column here, all right, and the third column there, you can see a very similar style that we actually support the APIscene transactions. You can start the transaction and you can actually make a few updates or select statements, and then you commit. This will go in as a batch, all right? So it's all in or nothing. At the same time, you have the save point, rollback, etc., etc. All of those functions are available there to support your transaction. Okay. So furthermore, some of you may actually ask and say, hey, I heard Couchbase is a memory-first architecture. What does that mean? Because it is asynchronous, that is eventually synchronized into the disk. How do we actually ensure the consistency on that part as well? So that is a very, very good question. The simple answer is we can do that. We give you the flexibility to choose what you want to do on runtime. So on SDK level or on a setting, either way, you can set the durable write. What does that mean? Imagine that you write the data first into the memory, okay? If you don't care about, whether, sorry, let me take a step back. When you write the data into the memory, if you have higher risk tolerance of data loss of that piece of data, you can ask for the handshake straight away, okay? That is a default setting. However, if you say you want a little bit more protection of the data, you can have a few more options down below. You can say, give me a handshake only after you replicate it into another node. Okay, remember we talked about the replication? The replication will get carried out as soon as the data get written into memory. Okay, so you can get a handshake after the data get replicated. But if you say, hey, that's not good enough, that's not good enough. I want to make sure that the data get persist in the disk before you can give me a handshake. Sure, we can do that as well. All right, so you can wait until the data get persist into the local disk, then we give you a handshake. Last but not least, if we want to give you the best possible protection, is we give you a handshake only after the data get written into majority of the node. Okay, in this case, we will guarantee you have the consistency. So with the APIscene support, APIscene transaction support, with the durable write flexibility that you can control on the runtime, we give you options. We give you different options. That means you can have a workload that have less concerns about the data availability, okay, and data consistency, to an extreme that you have transaction that you want to ensure that the data don't get lost in any means. Okay, you have the flexibility to do both ends of the spectrum. I hope that makes sense. Also, we have a number of different features in Couchbase API that we can actually support different requirements or different functions from the application in the database. right? There are analytics services that we can actually help to doing operational analytics, all right? Ad hoc queries, large data sets. And again, analytics is another consumer of DCP, the data change protocol that we talked about. So what it does is actually it copies the data into a separate MPP database. So again, analytics services is elastic. It is multidimensional scaling. If you remember that diagram, you saw analytics, all right? So if you need more compute or you need more processing power, then you can actually only scale that services. And also we have fully integrated full text search, all right? And then a SQL engines on top of the key value operations. Okay, so that means we were able to give you a lot of familiar operation. You don't need to go and learn a completely new language. You can actually have index built for full text search and SQL. Then you can actually reuse your SQL skill sets that help you to build your application a lot faster. But obviously, if you want the best performance, KV store, KV operation, key value operation is still the best possible ways to retrieve the information from the database. So all in all, that actually conclude the first option, that Couchbase have the ability to help you to do a lift and shift. Okay, from there, then you can either over time you can plan your modern application to from your application layer so that you can start doing the monolithics to microservices architecture migration. All right. Now, again, one thing to make sure that we are on the same page is that let's talk about that later. While you're actually doing application layer from monolithics to microservices architecture, if you want to do it in a phase approach, okay, a phase approach, it is very, very important to keep the database synchronized in that way. Okay, so obviously there are many different patterns that you can do. So today I'm not going to dive into that details, but just keep that in mind that you would like to have the underlying database synchronized when you are doing, the phase approach. Again, Couchbase can actually help in a big way for you to do that. But today I'm not going to deep dive into that. All right, second option you got is we put Couchbase in as a cache layer. Okay, so you have a legacy Oracle database, doing its things just fine. But if you need further expansion, it's just too expensive, too rigid to scale. So in this case, we put the cache layer. All right. So this is a architecture that tells you on the right application. This is only showing one pattern again. One pattern of what cache can do. There are many other patterns like the right behind, the same other things. I'm not talking about that here. I'll just give you one example of particular caching architecture patterns here. So this one is allowing the application layer to determine, when to write and how to read. Okay, so when it's writing to the database, it writes both into the cache and the database. So that's the left-hand side one. On the right-hand side one, when the read, all right, the application will first try to read from the cache. Okay, if the cache is not available, all right, it's no longer is cache, right? Then we'll actually read that from the database. It's all controlled at the application layer. Okay, so in order for a database to play in a cache, all right, it obviously have a lot of advantage, but you have to be able to perform. You have to be able to scale and give you high availability, and it needs to be easy to manage. All right, and obviously it needs to be very simple and affordable. We'll talk about that. So I think at the right beginning, we actually talk about, the performance memory first architecture can guarantee your performance. the scalability we talked about, right? For those one who joined late, we were actually talking about the MDS, the multidimensional scaling, as well as using Kubernetes to scale. And availability, the high availability, the inter-cluster replication, again, that gives you the high availability auto failover, as well as the inter-cluster replication, the cross data center replication that is available, right? So in order to do that, this is a Couchbase solution for caching, right? So the application will determine the read-write access request. Will actually send it to Couchbase. Will actually have the replicas make available as well. But at the same time, if the caching is missing, and then we actually get the right request from the RDBMS database as well. All right. So performance at scale, right? And we are actually memory and network centric. It's always on, from the edge to the cloud. We can actually deploy everywhere. It is very consistent performance at any scale, right? So it's a linear equation you plot out there against your size of your cluster. It is very, very consistent. And we talked about the workload isolation as well, so I'm not going to repeat that. Also, Couchbase is very easy to manage and very easy to use, right? So we talked about the Kubernetes, using Kubernetes to deploy it, right? You can actually deploy in the cloud or on-prem or private cloud, public cloud, any of the cloud vendor, right? It's very easy. And obviously security is a very important aspect of that as well, okay? Deploy with agility. Here we actually talked about, with JSON document that give you the flexibility on schema, and will also give you the flexibility to migrate, all right, to actually do any mapping. You can do a fully de-normalized data model, or you can be normalized. You can make it as close to the application as possible in terms of the schemas and the data model, right? In this case, it makes it very, very easy for the application to retrieve the data to serve the purpose. So in this case, having a Couchbase put in as a cache, okay, and then from there that you can think about your modernization journey from monolithics to microservices, okay. The third option, obviously, well, you actually say, you know what, my application and my database is too old, right? If there are too much effort for me to do the migration, to do the upgrade, etc., why don't we just build one from scratch? Okay, there are customers that actually thought the effort, and the overhead to manage, the infrastructure to get through that journey is too difficult, all right? And some of them actually designed to build it from scratch. So obviously, we talked about the 4 patterns that allow you to do new application, that we allow you to build something from scratch, okay? So here's a summary, right? We talk about the 3 options. The first one is a lift and shift and modernize. That means you move your database first, then modernize your application. The second option we actually talk about is you cached it, put a caching layer for the legacy database, then you actually modernize your application. So the last one is obviously building a new application, big bang, there you go. So it's different consideration for different scenarios, right? So if you are required to get off the existing database immediately, and obviously the lift and shift give you the flexibility to get onto a modern database first, then you talk about your modernization journey at the later stage. But if you are not allowed, or you don't have an immediate plan to retire any legacy database, but you also require some scalability and performance, right? And in this case, your modernization journey is a bit fuzzy. This actually happened in a lot of our enterprise customers, right? So they have a legacy mainframe or Oracle or any of the RDBMS out there. They are not allowed to touch it because it's too much risk, all right? So what they want to do and what they normally do is they put in a caching layer in front, okay? And we can actually help you with that. The good thing about that is over time, the Couchbase have the ability to play more than just cache. So basically you have us there and we have many use cases that we start with a caching layer. Then over time, we'll actually grow as the main database of the application or across a set of application for our customers, because it have the flexibility to do only caching or the main source of the database, general purpose database as well. Obviously, last but not least, when your application have very complex business logic with interdependency, you don't really understand what that is. It will be very difficult for you to, to do migration. Okay, an outcome-based approach could be something that a lot of customer will think about. We're actually looking at, okay, it has been there for 15 years. It is working. That's fine. But the next generation, should that be in the cloud? Should we actually looking into different functions altogether? Right. And some of our customers actually chose a journey to do building a new application, completely new. So it's no relationship with the old one whatsoever. So in this case, Couchbase can help in all of those scenarios. So let me just pause here for two seconds and see whether there's any questions or concerns. Okay, I take the silence as no, or maybe you all fall asleep. So let me quickly wrap it up. Okay, so Couchbase is a memory-first multimodal architecture, right? So we actually talk about the how you can access all of those functions via the SDKs and the APIs, all right? And you have the JSON documents, key value store, and you have a lot of integrated services, including analytics, full text search, a SQL++ engine that support ANSI transactions. We are fully scalable, have high availability, etc., etc. It is a distributed cluster. One thing we have not talked about, but Jeff actually mentioned very heavily yesterday, is a cloud deployment. All right. So briefly touch on the Kubernetes, the way how we use Kubernetes to deploy it. And we also have a database as a service available in the cloud as well. So if you're interested, please feel free to try that out. At the same time, one of the other topics we have not talked about is the mobile at edge, right? What that allows us to do is it allow us to help our customer to provide a offline first mobile experience. What does that mean? Think about some application that will still work without network connections. Okay, so an insurance company, when the sales agent is trying to make a sales at the garage or somewhere that doesn't really have access, the timestamp and the documents still can be accepted and uploaded to the apps. When the agent went back to anywhere that have internet connections, the data will get automatically synced back to Couchbase server with a component called sync gateway with conflict resolution and all that, right? So today we're not going to spend too much time talk about the mobile, but if you are interested, we can obviously have different sessions to talk about that as well. And not forget to mention about security, all right? Authorization, authentication, very important. Fully enable row-level security as well. At rest encryption, turn on by default. Transport level security, turn on by default. So you can actually trust, doesn't matter where the data goes and where it stays, it was fully protected. So after you hear all of those, how do we get started? All right. So obviously there are different things, and I'm not sure whether you can have your access to this stack, but if you do, click on each of those, it will actually get you to the database as a service. You can actually go down there and you can sign up. It takes you 5 minutes to spin up a Couchbase cluster, and you can start using it. On the training courses side, we have all the available training courses for free at the entry level. All right, so go to the academy.couchbase.com, select the one that appropriate to you. What you need is your email address. Again, there are a lot of self-paced training that is available for you. All right, and obviously documentation as well. Documentation will give you a lot of guidance and a lot of tutorial and blog posts. All right, don't miss out. As you can see, if I hop over, you actually have a link there. If you have access to that, please click on those links, then you can actually get started. And there are a few more other options as well, right? And I'm also running a Couchbase masterclass next week as well. There are 2 sessions. If you have a phone with you now, please use your camera to scan that. Subscribe. In that session, we're going to talk about a lot of Couchbase fundamental. Open a box for you. You can have much better understanding in terms of how Couchbase works. But on top of that, you have other informations about, there is a sandbox environment called Couchbase.live that gives you a lot of SDK sample code. This is a Couchbase on the browser sessions, and that you have is available. And there are a few other white paper and webinar that you can watch as well. So moving from relational high performance with distributed cache is a white paper. I recommend you look at that as well. So yeah, like I said, thank you. If you like, scan the QR code, connect with me on LinkedIn, and I'm more than happy to discuss further with you in terms of how we can actually help you on your application modernization journey. So this is Genie Yuan from Couchbase. Thank you very much. I'm not sure whether Sean Ong is still there. I forgot about